Yeah, hi students. Let us continue to discuss about the friction part. Total engine friction. Here in this class we are going to discuss about the total engine friction. Total engine friction is defined as the difference between the indicated horsepower and the brake horsepower. So this is the difference between the indicated horsepower and the brake horsepower, which includes the power required to drive the compressor or scavenging pump and the power required to drive the engine auxiliaries such as oil pump, coolant pump and fan, etc. Total engine friction can be divided into 5 main components. Total engine function can be divided into 5 main components. They are crankcase mechanical friction, blow-by losses, exhaust and inlet system throttling losses, combustion chamber pumping loop losses, and the fifth one is piston mechanical friction. So, we have 5 types of components for friction, engine friction. So, engine friction can be divided into 5 major components. The first one is crankcase mechanical friction. Second one is blow-by losses, that is compression expansion pumping losses. Third one is exhaust and inlet system throttling losses. Fourth one is combustion chamber pumping loop losses. The last one is piston mechanical friction losses. So let us discuss one by one. In the crank mechanical friction can further be subdivided into 3 types. The first one is bearing friction, second one is valve gear friction, and the third one is pump and miscellaneous friction. The bearing friction includes the friction due to main bearing, connecting rod, bearing friction includes the friction due to main bearing, connecting rod bearing and other bearings. Bearing friction is viscous in nature and depends upon the oil viscosity. So, it is viscous in nature and depending on the oil viscosity, the speed size and geometry of the journal. All the crankcase friction losses other than bearing and valve gear losses vary roughly in proportion to engine displacement and speed. The bearing losses are affected very little by the loading of the bearing, but they rise rapidly with the increase in speed because these losses are primarily the result of continuous shear of the oil film in the bearing clearances. So, we can think about the bearing losses. Okay, we can avoid the bearing losses. The second one is the blow-by losses. Blow-by losses is the phenomenon of leakages of combustion products past the piston and piston rings from the cylinder to the crankcase. These losses depending upon the inlet pressure and compression ratio. So, blow-by losses are depending upon the piston, depending upon the pressure and compression ratio. These losses vary as the square root of the inlet pressure and increases as the compression ratio is increased. Blow-by losses are reduced as the engine speed is increased. We can reduce the blow-by loss by reducing the by increasing the speed of the engine. Let us continue the remaining part in the next.